All right, welcome to the maths class. We will continue our discussion on linear equations in one variable. Last class, we learned a faster technique to solve simple linear equations. See, we know there are four rules, right? Whenever you have an equal to sign, that is indicative saying that we have an equation. And we can add, so there is a left-hand side and there is a right-hand side, okay? We learned there are four rules to solve linear equations. We can add, subtract, multiply or divide, same thing, same quantity on both sides. So that was our four rules in the very first class we did. Then we learned a faster and more efficient technique called transposing. So what was transposing? Transposing, where we can directly move operands or entities from one side to the other side. So we learned when plus moves across the negative sign, across equal to sign, it becomes negative, correct? So that is one technique. Second is, if you have negative which jumps to other side, it becomes positive. So that was your second technique. Third was, if multiply jumps over equal to sign, it becomes divide, and if divide jumps over equal to sign, it becomes multiply. So we have successfully used all of this to solve simple linear equations. For example, it could be any kind, like 2x plus 5 equals to let's say 16. And we have successfully used, we can transpose this positive 5 to the other side, and you get 2x equal to 16 minus 5, which is 11. And then you can divide by 2. So you can transpose this multiply of 2 to the other side, it will become divide. So it will become x 11 by 2, which is 5.5, or 11 by 2 can be the answer. So that is how we used. Then we learned a different class of problems where equation is not given. Some statement is given. And you are supposed to create an equation. And we use our knowledge of algebra to create. Something will be unknown, some relation will be given. Whatever is unknown, we assume that to be some variable letter. For example, x, y, n, p, q, something. Whatever is your best liked letter, you can use that. And then we create an equation and then solve it. So towards the end of the class, I told you, what are consecutive numbers? How do we assume numbers? If somebody says consecutive equal numbers, even numbers, consecutive odd numbers. So I told you, if it is consecutive numbers, then you can assume numbers to be x, x plus 1, then x plus 2, and so on. Basically, every number is one more than the previous number. So that is how you chose consecutive numbers. But somebody says even numbers, then consecutive even numbers. Then first number can be x. See, we are talking about even numbers. So 2, 4, 6, every jump of 2. So next number will be plus 2. The third number will be x plus 4, and so on and so forth. Even when you have odd numbers, you can choose very similar strategy. So that helps you to form equations. Let me give you one question, and let's see how we can solve it. Okay. So first we will do some questions like this. Then today, we will upgrade our skills to use transposing to solve a different kind of questions. Okay, so I have a presentation on which I have question, and I want to share with you, and we'll solve it there. Okay, and let me share here. All right. So can you see the question? Sum of 3 consecutive even numbers. So again, we are given consecutive even numbers. How many? 3 of them. is 252. So find the numbers. We are supposed to find the three numbers. And how would you solve that? So again, we don't know the numbers. So we start with the basic assumption. Let the first number. So we'll assume let the first number be x. So if we have assumed first number to be x, what will be the second number? The second number, so we are talking about consecutive even numbers, which means jump of 2. So second number will be x plus 2. And the third number would be x plus 4. So now we got our numbers. And it's the, what is the question? Sum of three consecutive numbers. So first number plus second number plus third number. So all the three numbers added is equal to 252. Now let's put the values. X plus 2 plus x plus 4 equals to 252. Now we can use our, see, now it's an equation, and that is what we were supposed to be solving. So how many x's are there? 1x, 2x, 3x. So 3x plus 2 and 4, 6 equals to 252. Now let's transpose. So we transpose plus 6 to the other side. What will it become? Minus 6. Yeah, that's correct. So 3x equals to 252 minus 6. So how much is 252 minus 6? 248. No, 246. So that is 246. Now it is 3x this side. What do? 3 is multiplying x. So we will again transpose 3 and we will bring it down as a divide. So then it is very easy now. X is equal to 246 divided by 3. So this will go as 3 8s and 2s. So 82 is x. So answer is not x equal to 82. What is x? X is first number. So we'll say first number is x is 82. Second number is, how much is the second number? X plus 2, 84. Third number equals to x plus 4 is 86. So these are our three numbers. See how we have used our knowledge of algebra and the techniques of solving linear equations to actually a word problem, or rather a statement. Okay, on the same lines, this is even number. Even numbers are what? Multiples of 2. If you are given consecutive numbers which are multiple of any other number, let's say multiple of 5, then every number will jump by 5. See, multiple of 5 means what? Table of 5. So 5 ones are 5, 5 twos are 10, 5 threes are 15. So if you see 5, 10, 15, everything is a jump of 5. Likewise, if you are given consecutive numbers which are multiples of anything, then every other number will jump by that number. So let's take another example and see what do I mean by that. So here is this. Sum of three consecutive multiples of 8 is 888. So we have three consecutive multiples of 8. So let's understand what is multiples of 8. So let's write multiples of 8. What are multiples of 8? 8 ones are 8, 8 twos are 16, 8 threes are 24, 8 fours are 32, and so on. Why did I write? See, all these are consecutive multiples of 8. Now what I want you to understand is, if it's multiple of 8, every other number can be found by adding 8. So 8 plus 8, 16. 16 plus 8, 24. 24 plus 8, 32. And the next number will be 32 plus 8, which is 40. So we got the trick. The trick is three consecutive numbers. Each number will be formed by adding 8 to the previous one. So now, do we know the three multiples? So let, again algebra, let the first multiple. The first multiple be x. So second multiple will be x plus 8. Will be what? X plus 8. And the third multiple will be x plus 8 plus 8, which is nothing but x plus 16. So now we have got our three multiples, x plus 8, x plus 16. Now it is saying sum of three consecutive multiples is 888. So, you know, the first plus the second plus the third is 888. First multiple, second multiple, exactly like the previous question. So now you can write x plus 8 plus x plus 16 equals to 888. See, once again we got a linear equation, and now we can solve. How many of x's? 3 of x's. Plus 8 and 16, 24 is equal to 888. Now transpose positive 24 to the other side. Plus 24 other side becomes minus 24. So 888 minus 24, which is 864. So what is x? We again transpose 3 to this side. So it will become 864 divided by 3, which is 3 to the 6, 26. 3 8s are 24 and 8. So 288. So now we got value of x, but answer is first multiple. First multiple is x equal to 288. Second multiple, we should add 8 to this, x plus 8, which is 288 plus 8. How much is that? 296. And the third multiple is x plus 16, which is 288 plus 16, and that would be 304. So this is your answer. So this is how we solve these questions which have consecutive concept, where we are talking about consecutive numbers, consecutive even numbers, consecutive odd numbers, and or multiples of any other number. So that was continuation from the last class. Now, have you noticed in all the examples and the questions we have solved, we always got linear equation. We always got linear. For example, we got here 3x plus 24 equals to 888. Or in the previous question, we had 3x plus 6 equals to 252. You know, in all these examples, the variable is only on the one side, either the left side or the right side. So that was very simple linear equations. Now today, we will try to solve some questions which have variables on both sides. Okay, and how does that change? How does it need a different skill? Actually, no. We are just going to use transposing skill. But we have to transpose variables also on one side. And what do I mean by that? Let's take an example. So let me take an equation, very simple equation, which has variables on both sides. So 7x minus 10 equal to 4x plus 11. So can you see? Now variables are on both sides. So what does this mean? What does this mean to us to solve linear equations? Actually, it just needs one more step. Why? See, what is that we want to find? We have to solve this for x, which means we are supposed to find value of x. So eventually what should I get? I should get x equal to something, some value. That is my whole purpose. I should find x equal to something. So x typically should be on the left-hand side and all the other. And that is the trick we are going to use. So we are going to transpose all x-related terms on one side. When I say one side, I not necessarily mean left-hand side. When we will solve some other questions, you will find out that sometimes it's better to transpose on the other side. But for now, just to start practicing, you can transpose on left side. So, and we can do many transposes together. What do I mean by that? Let me show you. So first, where we find x here, so is it positive or negative? Positive. So we'll transpose this to this side of the equation. See, it doesn't matter transposing is from left to right or right to left. The moment you jump across equal to sign, you have to change. So this will become 7x minus 10 minus 4x equals to 11. See, 4x is already gone, so you're left with 11. That is step one. Step two. What do you see here? There is a minus 10 constant sitting here. And we'll make minus 10 jump across this side. So when minus 10 will jump, what do we get? 7x minus 4x. See, 10 has gone from here, minus 10. And this side we had 11. And now 10 comes and adds to this. So it becomes plus 10. Now we got a very simple equation. See, what is 7 of x is minus 4 of x? 3x. So 3x equals to 11 plus 10, 21. Now 3 is multiplied to x, transpose one more time. And we get x equals to 21 by 3, which is 7. Easy? So we got x equal to 7. That's my answer. So, being variables on both sides, did it change anything? No, it added one more step. Okay. Now, let me show you what happens if I do two transposes together. It will become even more faster. What do I mean by that? So, let me show you. Let me see if I have a blue pen. Okay. So, suppose this is the equation, right? So, you see x has to go this side. And 10 should go this side because it's a constant non-x term. So we will do two transposes. 7x minus 10 equal to 4x plus 11. So my first transpose is take 4x this side. Correct? I am taking all x's. And I will also do minus 10. I will move this side. So now you should be very careful in writing what is left. So what is left here? 7x. So we'll write 7x. Now this 10 has gone out, so we should not worry about 10. 4 is coming this side. So it's positive, it will become negative 4x. Okay, now let's look at the right hand side. 4x has gone out. What is left? 11. Now what is coming in? Minus 10 is coming in. So which means it will become positive 10. So we get positive 10. So you get 3x equals to 21. So x equals to 21 by 3. Which is 7. So now, can you compare the old method and the new method? Nothing has changed. See, here the first transpose in step 1 and second transpose in step 2. And I have combined the step 1 and step 2. So you go from here directly to here. So one more step efficient. So that is how you can use your transposing. But this needs practice, okay? Because sometimes you get mistaken which has moved, where has moved. So that is why I circle, so that you can see for yourself. Initially, in your rough, you can circle with pencil. Then, when you practice and you become more expert at it, you can solve them breeze, fast. Okay? Easy? Now, let's take another one. And this time, I take a slightly different question so that it gives you how to handle. I have a fraction involved. Okay? So 3 by 4 x minus 1 is equal to x minus 3. Now, you remember in one of the classes I told, whenever you see denominator, take LCM of all denominators and multiply the whole of left side and whole of right side by the LCM. That technique can be used anytime you have a fraction. And since that is a very powerful technique, we should practice it more and more. So how many denominators do you see? Nothing, only one 4. So LCM is 4. So LCM is 4. So now I should multiply the whole of left side and whole of right side by 4. Now remember the importance of the word whole of left side. So what is whole of left side? This whole thing. See, this is right hand side and this is left hand side. So we'll put all of this in the bracket and multiply. So 4 into 3 by 4 x minus 1 equals to 4 into x minus 3. So now can you see whole of left hand side, whole of right hand side. That is very common mistake by students. So now when you open the bracket, 3 by 4 into 4, you will get 4 ones are 4 ones are. So this is left as 3x minus 1. And this is 4x minus 3. Now it is very simple. We can open the bracket. Remember, you know how to open the brackets, right? Distributive law. Whatever is outside the bracket is going to multiply this and this. Likewise, this and this. So this will become 3x minus 3 equals to 4x minus 12. Okay, very simple. Now, you remember, we should get all the x's on the left-hand side. But you see, there is a 4x sitting this side, which is a bigger than this x. So sometimes it's easier to post that way. But we'll not do that. For now, take all the x's to the left-hand side. So I transpose this one this side. So positive 4x will become negative 4x. And I will transpose negative 3 this side. So negative 3 this side will become positive 3. So what does this mean? This means 3x minus 4x equals to minus 12 plus 3. So always write first the existing terms and then the new additions. So 3x was existing. I wrote minus 3 has gone out. So I don't worry about that. 4x is coming in as minus 4x. So then minus 12 and then 3 is coming. So now it's very easy. 3x minus 4x minus x. Actually, it's minus x. Then minus 12 plus 3. Different signs. Sign of the bigger. So negative 9. Negative 9. Now, how do you deal with this? When you have negative both sides. Actually, what does it mean? You can cancel minus sign both sides. But reality, what happens? You actually multiply both sides by minus 1. Remember, I can multiply equation both sides. So minus 1x into minus x is x. And minus 9 into 9, minus 1, 9. See, negative both sides got cancelled. But actually what is happening is minus 1 gets multiplied both sides. So you can do that. Okay. So that is how you can transfer minus signs from left to right or cancel minus signs. So minus 1 is the technique. So x equal to 9 is the answer. So now you see, we use two very important techniques. LCM technique and double transposing. Transposing many times. Many of them in one. Which is to, will your answer change if you transpose one by one? No. It is just one extra step. That's all. If you find it very confusing, don't do it. Transpose one by one and you will be absolutely fine. Okay. So let me take one more fraction question and we practice LCMs again. Okay. So now here. So this question I'll write and you guys try. And then 2x by 3 plus 1 equals to 7x by 15 plus 3. Again, you see fractions. Many fractions are there with different denominators. There is a 3 denominator. There is a 15 denominator. And it doesn't matter which side. As long as you see denominators, you take LCM of all of that. LCM of 3 comma 15. How much is that? 15. You can try. You know how to do LCMs, right? Okay, so 15. Now we'll multiply whole of left side and whole of right side by 15. So let's do that. So take all of this into 15 and take all of this into 15. Oops. Remember, whenever I want to do all of it, I put a bracket, because if you don't put bracket, it will become wrong. So now we see 15 multiplied with two terms or many terms in the bracket. So 15 will multiply with each of them. So what do we get? 15 into 2x by 3 plus 15 ones are 15 equals to 15 into 7x by 15 plus 15 into 3, 45. Simple. We have just opened up. Now you can cancel 3 ones are 3, 3, 5. So that is 10x plus 15 equals to 15 and 15 one time. So that is 7x plus 45. Easy. Again, very simple equation now. We will transpose. This goes this side and positive 15 goes this side. So plus x plus 7x this side minus 7x. So 10x minus 7x equals to 45. And this plus 15 goes the other side. It becomes minus 15. Okay. So what do we get? 3x, 10x minus and 45 minus 15 is 30. Very familiar situation. We will divide, we'll transpose. So what do we get? X equal to 30 by 3, which is x equal to 10. So that's your answer. Once again, all the techniques which we have learned in the previous question are used. LCM technique, multiplying the whole left-hand side, right side by LCM, double transposing, then finally one single transpose to get to the answer. That is the template to solve this kind of linear equations where your variable may appear on both sides. And it doesn't hurt. Okay? So you're well equipped. Now I have again some situations where equations are not given. Statement is given. And we'll try to convert them also into equations and try to solve them. Okay, and there are many of these kinds, especially the digit related, the age related. Okay, so let me give you a brief technique of how to solve these kind of questions. You know how number place values are? You know, right? Units, tens, hundreds, this kind of place value. So how does a number get formed? Suppose you have tens and units. So if I write 7 or hundreds and 3 and 2. So this is your standard form. And if you want to write expanded form, that is, see, this is place value of 100. So we multiply, this is place value of 10, and this is place value of 1. So this is 2 into 100 plus 3 into 10 plus 7 into 1. Isn't it? This is how you write expanded form. So when you have questions related to digits, which you will have, what do we do? If we replace these digits by ABC, then how will I get my number? We simply change the digits. The place values remain same, A, B, C. So you will get 100A plus 10B plus C. That is your number when digits are A, B, C. So most of the digit questions, we are going to use this technique. Okay? So that is one kind of problems. Second are age-related problems. All the competitions, all the questions in exam, you will get age-related problems. How do we understand age? So first here is, you are all 8th graders, right? So you must be what? About 13 to 14 years old. So you are your present age. So let me take your present age is how much? 14 years. We'll take one example, 14 years. So what will be your age 3 years from now? After 3 years, what will be your age? 14 plus 3? right? 17 years. After 10 years, your age will be 14 plus 10. So that is how you do afters. Okay, if you are 14 now, 4 years back, what was your age? 4 years back. So if I were to write on a time scale, 4 years ago, what was your age? 14 minus 4, right? 14 minus 4. That was your age. 10 years ago, or 7 years ago, 7 years ago, 7 will be 7. So let's say 10 years ago. So 10 years ago, what will be your age? 14 minus 10. So this is how you assume. So if your present age is X, then your age after 3 years will be X plus 3. Age after 10 years will be X plus 10. Your age 4 years ago was X minus 4. And your age 10 years ago was X minus 10. If you understand this, all the age-related questions you can solve. I guarantee you that. Okay? And how to do that? Let's see. Let me see if I have time. Otherwise, in the next class, we'll continue these techniques. Now we still have some time, and we will do some questions on these English statements and see how best we can solve these kind of questions. Okay? So let me share the presentation back with you, and we take it from there. Okay, so here is the digit question. Can you read the question? Sum of digits of a 2-digit number is 12. If the new number formed by reversing the digit is greater than the original number by 54, find the original number. So first of all, there are 2 digits and they add up to 12. So if digits, right? So digits can have value from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the only possible values. So if one digit is 9, the other one has to be 3. If one is 9, the other has to be 3. If one is 8, it has to be 4. 7, 5. Basically, their sum should be always 12. So this is the way. So how do we write? If one is 9, the other one has to be 12 minus 9. If one is 8, then the other one should be 12 minus 8. This is 12 minus 7. So that is how you write. And this is exactly how we are going to write. That our digits, sum of 2 digits is 12. So how do you find a 2-digit number? You have tens, units. So let's say your units digit is X. So your tens digit will be 12 minus X. You can choose any which way. You can say tens digit is X. It really doesn't matter. So this is my original number. Okay. So first thing is I have put digits. So now based on these digits, you multiply by the place value to get the number. So your number will be 10 into 12 minus X plus 1 into X. Correct? That is how you get your original number. So how much is that? So that is 120 minus 10x plus x. So that is 120 minus 9x. So that is my original number. And now it says, if a new number is formed by reversing the digits. So new number. So we are forming a new number. By reversing the digits. So now tens and units. The digits will reverse. See, it was x here, right? So x will come here. And this will become 12 minus x. So what will be the new number? 10 into x plus 1 into 12 minus x. So that is 10x plus 12 minus x. So that is 9x plus 12. So this is These are your two new numbers. And it says if the new number found by reversing the digits is greater than the original number. Oh, so the new number is bigger than the original number by 54. So what does it mean? That if you take the new number and subtract original number, then you should get 54 because it's bigger by 54. So we can say like this, new number minus original number is 54. So now we can substitute the values. New number is what? 9x plus 12. 9x plus 12 minus the old original number is 120 minus 9x equals to 54. Now it's pretty straightforward. Let's open the brackets. 9x plus 12 minus 120 plus 9x equals to 54. So this is 18x and minus 108 equals to 54. So you get 18x equals to, so we'll transpose this the other side. We'll get 108 plus 54, which is 261. 1862. All right. So now it's very easy. X is equals to 162 by 18, which is how many times? 9 times. 18 nines are 162. So we got X equal to 9. So is that my original? We are supposed to find original number. So what is our answer? Original number. Original number is tens and units. So this is 9 and this will be 12 minus 9. So it is 3. So our number is, so original number is 39. That's our answer. Or you can put in this also, 120 minus 9x. And you can see for yourself what is the answer. All right. So you see how we did the digit related questions exactly using. And in the next class, we will practice age-related questions also. And we'll see some different kind of linear equations where we can use again the same techniques to solve them. So see you in the next class on linear equations, solving little more higher end questions and age-related questions. All right. Thank you so much. See you again. Bye.